If you've ever wondered what your chances are of either drawing an ace in a card game or maybe rolling a 6 in a dice game, then this probability lecture will be helpful to you. Probability is fundamental in dice and card games because it influences people's strategy and decision making. So let's first define probability. Probability is equal to the number of favorable outcomes divided by the number of total possible outcomes. So with this definition in mind, let's look at the probability in dice games. Let's say you have a 6-sided die. The total possible outcomes when you roll this die are 1, 2, 3, 4, 5, and 6. So if we want to find the probability of rolling a 4, we would take the one possible 4 outcome from these 6 total possible outcomes, and we would say 1 divided by 6. That's the probability of rolling a 4. So now let's look at an example with 2 dice. It's two 6-sided die. So the total possible outcomes when rolling 2 6-sided die are 6 times 6, because there's 2 6-sided die, so there's 36 possible outcomes. So if we want to look at the probability of rolling a double when rolling 2 6-sided die, well, our number of favorable outcomes is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and finally 6, 6. This is 6 ways. So, to find our probability of rolling a double, we take those 6 ways divided by 36 total possible ways is, again, 1 over 6. So now let's look at the probability of rolling an even number with 2 6-sided die. So to roll an even number, you have to do either an odd number and an odd number, or an even number and an even number. So the possible outcomes are 1, 1, 1, 3, 1, 5, 3, 1, 3, 3, 3, 5, 5, 1, 5, 3, and 5, 5. As well as 2, 2, 2, 4, 2, 6, 4, 2, 4, 4, 4, 6, 6, 2, 6, 4, and finally 6, 6. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 ways to roll an even number. So the probability of rolling an even is 18 divided by 36, which equals 1/2. Now let's look at probability in card games. In a standard card deck, there are 52 cards. There are 4 suits. There's diamond, heart, club, and spade. And in each of these suits, there's 13 cards. So let's first look at the probability of drawing a spade. Well, there's 13 spades in a 52 card deck, which is equal to 1/4. You've got a 1 in 4 chance, which makes sense because there's 4 suits in the deck. So, I mean, out of drawing a random card out of the deck, you've got 1 in 4 chance of drawing a spade. But now let's look at the probability of drawing an ace. Well, there's 4 aces in 52 cards. So that's 1/13. You've got a 1 in 13 chance of drawing an ace. Now let's look at the probability of drawing an ace twice in a row. And when I say twice in a row, I mean in succession. So we're looking to draw 2 cards from a deck without replacing them, and we want both of them to be an ace. So we've already found the probability of drawing an ace first is 4 out of 52. Drawing an ace second would be 3, because you've got 1 less ace, out of 51, because you've got 1 less card. So the probability of drawing an ace twice, you would take these probabilities and multiply them together, which is a 1 in 221 chance. Let's say you wanted to draw, or let's look at the probability of, well, let's look at poker hands, okay? This is a real world application, poker. And let's define a flush as having 5 cards, all of the same suit. So you could have 5 diamonds, 5 hearts, 5 clubs, etc. So to find the probability of a flush, we've got to look at 2 things. We've got to look at the number of ways to choose 5 cards from 13 in a suit. And we've also got to look at the number of ways to pick 5 cards from 52 cards. So let's look at the number of ways to choose 5 cards from 13 in a suit. And the way we find this is we say 13, choose 5. Which is equal to 13 factorial over 5 factorial times 13 minus 5 factorial. And when I say factorial, I mean 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So you do that for 13, you do it for 5, and you do it for 8. And this comes out to equal, I'm not going to try to pronounce this number because it's too big for me to pronounce. But you end up with this number, which is equal to 1,287. Now, because a flush is 5 cards of any suit, and there's 4 suits in a deck of cards, we've got to multiply this number by 4, because we are not sure like what suit we're looking for. We're just looking for 5 of the same suit. So that means that our probability is already multiplied by 4. So now let's look at the number of ways to choose 5 cards from the 52 deck card deck. Again, we're going to say 52, choose 5, which is equal to 52 factorial over 5 factorial times 52 minus 5 factorial. And this comes out to equal 2598960. So to find the probability of a flush, we take these two numbers, so 4 times 1,287 divided by this number right here, and that equals 0.00198, which is 0.198%. And some real-world applications of this are casinos. Casinos will rig their games for their benefit. So the probability of the casino winning is always going to be higher than the probability of the player winning. So in conclusion, probability is essential in games involving dice and cards. And next time you play a card game, think about how probability can affect your strategy.